Assalamu alaikum. My name is KARRAR. I'll be talking about wind power generation. This is my group members. I'll be talking about introduction. Meaning of wind power generation. Wind power or wind energy is used of wind turbines to generate electricity. Wind power is a popular, sustainable, renewable energy source that has a such similar impact on the environment than burning fossil fuels. Wind farms consist of many individual wind turbines which are connected to the electricity power transmitter network. Types of wind turbines. We have two types of wind turbines: vertical axis wind turbines and horizontal axis wind turbines. Application of wind turbines. First, land-based wind turbines, also called as offshore wind power. Turbines that are located on the land and use wind generating electricity. They are generally located in area where there is low conservation or habitat value. We have offshore wind turbines. Typical out at sea, there is a much higher wind speed, allowing for more energy to be generated at time. There are no physical restrictions such as hills or buildings that block the wind flow. Offshore wind farms can be expensive to build. Third one, we have distributed wind turbines. Wind turbines of many sizes are installed on the customer side of the electricity meter. Produce electricity on the distributed grid from homes, farms, schools, and businesses.
Assalamualaikum. My name is Muhammad HAFIZ bin ISMAIL. I want to explain about basic construction of wind turbine. First of all, the basic component of wind turbine has three. The first one is tower, second the nacelle, third the rotor blades. Next, erecting the tower. Although the tower steel parts are manufactured off-site in the factory, they are usually assembled on-site. The parts are bolted together before erection. The tower is kept horizontal until placement. A crane lifts the tower into position. All bolts are tightened and stability is tested upon completion. Second one, the nacelle. The nacelle is made from fiberglass like the tower. It's manufactured off-site in the factory. Unlike the tower, however, it is also put together in the factory. Its inner workings, main drive shaft, gearbox, and blade pitch and yaw control are assembled and then mounted into a base frame. The nacelle is then bolted. As for the picture show the inside the nacelle. Next is the rotary blades. Rotary blades is aluminum blades are created by bolting sheets of aluminum together, while wooden blades are carved to form an aerodynamic propeller similar in cross-section to an airplane wing. The blades are usually bolted into the nacelle after it has been placed into the tower. Because assembly is easier to accomplish on the ground, occasionally a three-pronged blade has two blades bolted into the nacelle before it is lifted, and the third blade is bolted on after the nacelle is in place. As we see in the picture, the blade and the hub picture. Thank you.
Next, I will be explaining about the operation and basic principle of wind power generation. So how do wind turbines make electricity? Simply stated, a wind turbine works the opposite of a fan. Instead of using electricity to make wind like a fan, wind turbines use wind to make electricity. So let's take a look at the diagram of the blade of wind turbine. A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. According to Bernoulli's principle, when wind flows across the blade, the air pressure on one side of the blade decreases due to the increase in velocity. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of the lift is stronger than the drag, and this causes the rotor to spin. Next, let's discuss about the basic principle of wind power generation. First, wind that contains kinetic energy blows toward the turbine's rotor blades. Then the rotors spin around, capturing some of the kinetic energy from the wind and turning the central drive shaft that supports them. In most large modern turbines, the rotor blades can swivel on the hub at the front so they meet the wind at the best angle for harvesting energy. This is called the pitch control mechanism. Next, inside the nacelle, the gearbox converts the low-speed rotation of the drive shaft into high-speed rotation to drive the generator efficiently. Then, the generator takes kinetic energy from the spinning drive shaft and turns it into electrical energy. Running at maximum capacity, a typical 2 MW turbine generator will produce 2 million watts of power at about 700 volts. Anemometers and wind vanes on the back of the nacelle provide measurements of the wind speed and direction. By using these measurements, the entire top part of the turbine can be rotated by a yaw motor, mounted between the nacelle and the tower, so it faces directly into the oncoming wind and captures the maximum amount of energy. If it is too windy or turbulent, brakes are applied to stop the rotors from turning for safety reasons. Next, the electric current produced by the generator flows through a cable running down through the inside of the turbine tower. A step-up transformer converts the electricity to about 15 times higher voltage so it can be transmitted efficiently to the power grid or to nearby buildings or communities. Lastly, homes enjoy clean, green energy as the wind power generation produces no greenhouse gas emissions or pollution as it operates.
Hi, I am Ahmad ZULHILMI bin AHMAD PAUZI, and I will continue this presentation on example of wind power generation site. For the first example, I'm going to talk about Alta Wind Energy Center project. This information I get from powern.com. Alta Wind Energy Center is also known as Mojave Wind Farm. As you can see in this picture, this is the view of the wind farm. Alta Wind Energy Center is also known as second largest onshore wind energy project in the world. This project is owned by Terragen Power and located in Kent County, California, United States. This project is cost about $2.875 billion and took around 4 years to fully constructed, which is from 2010 until 2014. In this project, there are 11 phases. The first phase is finished on January 2011 and the last phase, which is phase 11, is finished on January 2014. In this project, there are 600 units of wind turbines, and the power generated is supplied to Southern California Edison. From the data we get, the average annual production from 2014 until 2019 is 3,189 gigawatt hour. That's all from me. I will pass the presentation to the next presenter. Thank you.
Assalamualaikum and hello everyone. I'm FARAH IDLIA BINTI IDRIS, so I will present about the second example of wind power generation site, which is Gansu Wind Farm project. Gansu Wind Farm is the world's biggest onshore wind farm, so attached here is the picture of the wind farm. The world's largest wind farm built at the poorest province in China to turn the lifeless Gobi Desert into an unlimited chamber of treasure. Gansu Wind Farm is located in the western part of Gansu Province in China, in the desert area near the city of Chushuan. It supplies energy to several provinces in China such as Liaoning, Zhejiang, and Guangdong. As we can see in the map of the People's Republic of China that provided in the slide, Gansu Province is located in the middle. Here is some of the information of Gansu Wind Farm. The cost for this wind farm is $17.9 billion. The construction of the wind farm started in 2009 and scheduled for completion during 2020. It has 7,000 wind turbines installed across the Chushuan, Inner Mongolia, Hebei, Xinjiang, Jiangsu, and Shandong provinces of Gansu, China. The energy produced by the wind farm is nearly 10,000 megawatt. The sheer power generation is a resultant of 7,000 wind turbines arranged in rows in the Gobi Desert. The plant capacity, if the wind turbine is fully operated, which is 100%, is 20,000 megawatt upon the completion of the wind farm. That's all from me. Thank you.